Hello, Zach. Congrats on the first. Making sure that we're live on YouTube. Okay. You ain't first, you're last. It's true. Cannot debate you there. Okay. So, I hope your stream was good. I saw you talking about, permutations. Um, the plan for today, barring a question from chat, is I'm going to be working on this 10-page maximum report that's due on Monday. It's for my scientific computing class. And basically the assignment was to, hey, BR Gaming, was to use Wavelet Transforms to detect edges in images. Because when you have a sudden change in color in an image, like with this guy's like shoulder against the sky, it suddenly goes from white to black. When you apply wavelet transformation right in that area, there's going to be a spike in the coefficients because there's a sudden change. Simple harmonic motion sucks. It does. And so what you can do is basically make a threshold value where if the coefficient is above a certain value, you keep it, and all the others you just set to 0. And if you do that, you get kind of like an automated edge detection algorithm. And so that's what is the right image here. It's kind of funny that the top of his head didn't come out so good. And I think that's because maybe there's like some frizz in his hair that makes the change not so sudden. What's my PC specs? Nothing very good. I don't know them off the top of my head, but I built this computer like 8 years ago, and it's really showing its age. The only thing I remember offhand is my graphics card is a 1660 Ti. I don't remember anything else though. Hey, famished. So yeah, this is like a stock image that we were supposed to use just to like test things out with. Actually, we did. It's snowing here. Ooh. And you don't usually get snow where you are, right? Hopefully it's not too much. It looks tasty. I can maybe see that. As long as it's fresh snow. BR Gaming. I would love nothing more than to build a new PC, but that costs a lot of money. It's an inch? Okay. That's not the worst then. What was I doing with this figure down here? Oh, I guess, okay, so with... Well, I don't want a $600 computer. I want a $2,000 computer. I don't think it's worth it for me to build a bad one. The 3050? I mean, that sounds like a good graphics card. I don't know much about hardware. Alright, so I guess what I was doing down here... Why does this image come out like crap here? I don't know. Hey, Energy. There's many different frequencies that the wavelet transform gives you. And you pretty much, for edge detection, you pretty much always want to use the finest one. For two main reasons. The coarser frequencies just give you coarser edges, so it's not as exact. And also, each level coarser you go, your resolution gets cut in half. So this one that, like, level 9 is the finest level, level 5 is what? We divide it in half 4 times the resolution here, so it's just a blob. Yeah, I'm not the best at probability, but you can ask. Ooh, I need to fix this. I made a mistake here. Open that up in just a second. Energy. There should be defined this L variable and I never used it. What did I okay, it's fine. L. I'm an expert at L's. Never W's. Oh wait, why did that shouldn't be this one shouldn't be here at all. Oh, I've missed it on the other. Oh my god. I think I was drinking when I wrote this section. There we go. I think it's better. Okay, let's see what you linked. Reichenbach's common cause principle. Suppose two events A and B are positively correlated. Probability of A intersection B is greater. Okay, yeah, I can see how that means a positive correlation. Started reading about probability theory because I plan on working in finance. However, I found the mathematics for calculating expected returns of stocks difficult for me to understand because in my experience they're pretty multivariable. That would make sense. Probability in general is a really tricky topic. I haven't really gone into financial math for myself, but with probability, it's one of those areas where it feels like you need to be like a lawyer, because half of it is like a word problem and interpreting the words exactly correctly. I suppose neither event is the cause of the other. Okay. Reichenbach's common cause principle states A and B will have a common cause that renders them conditionally independent. Maybe, yeah. Oh god, this is a lot of words. Use it to describe a purported macro-statistical temporal asymmetry in analogy with the second law of thermodynamics. Macro-statistical, so statistics at a high level, I guess, so like the population level maybe or something. Temporal asymmetry. So it's getting less symmetric over time, these macro statistics. Second law of thermodynamics, is that entropy? Okay, yeah. If the probability of A and B being correlated is greater than the probability A times probability B, either A causes B or B causes A or C causes A and B. It sounds like they're saying, as how I'm interpreting this sentence here is it's the third thing you said, energy, that C causes A and B. Because they do say neither event is the cause of the other. Principal significance of positive connection between causal structure and probabilistic correlations, thus facilitating causal inference. Okay. Captain Vic9, thanks for the follow. Okay. Let's see if we can get an idea. So they say that's controversial. We might skip to that section. Probably both A and B occur. because one of the following causal relations exists. A is a cause of B, B is a cause of A. Okay, so this is what you said exactly. Energy. Don't quite know offhand what this is saying. These conditions. I guess this is saying the conditionally independent, where A and B might appear to be dependent based off this relation. But they might actually be independent if you realize this cause C exists. Simpson's paradox. Oh god, okay, I'm not gonna... This is a little... Scorpra, why didn't that work? Also, the music is a little loud, sorry. I hope you're doing well. It's been a minute. You heard it? Why didn't I hear it? That's weird. Oh, I heard that. Okay. Um. Okay, maybe that's a little bit more of a rabbit hole than I should go down. See, I mean, I personally don't see the issue so far. So maybe we should skip down to the section that talks about that. What does the word putative mean? Putative. Considered or reputed. Okay. Number of authors propose counterexamples to the common cause principle. Counterexample involve two events A and B such that A and B are probabilistically correlated. Neither event is a cause of the other. Relation between A and B cannot be explained by common cause, either because they have no common cause or because their common cause did not. The screen them off phrasing, I don't know what that means. Okay, so if this is... It's saying things could be correlated without causation. Hey, Skirtle. You not on Twitch much these days? That's fair. Sometimes you need a break, or you just are more into other things. I haven't been on it as much myself the last, like, 2 weeks. I feel like this is pretty... I feel like this is a kind of an exotic counterexample. Addiction to Fallout 76? That's a very fair reason. Have you been watching the TV show? I'm all caught up. Don't ask, don't say. Everything lies in silence. Ooh. That's a cool fortune. been good. Yeah, I really love it. I mean, I do have some gripes with it, but overall, I really love it. Started playing Fallout New Vegas. Oh hell yeah, famished. I mean, okay, it's probably not as good today because it's kind of gotten old. But as long as you can look past that, you're in for a treat. That's my favorite game of all time, and you probably know that already. Selling you Saibao. What does that mean? Shut up. I don't know. People play stuff stream older games. Yeah. There's definitely an audience for older games. I mean, hell, DayZ is 14 years old? 13? I don't know. Shut your bitch. Oh! I thought that was like a Tagalog word. I was actually thinking about opening up Google Translate and typing that in. The 4GB patch your graphics won't go crazy on you. I mean, I never modded my... Well, I guess you're saying a patch, not a mod. I think that there are mods that are supposed to fix the game. Playing via GeForce. Strictly business since it's old. GeForce now can run all games, no lag and crashes. Noish. Oh yeah, just make sure. You might have already heard this tip, but keep multiple saves, like maybe two, like at least two, but like three is even better. And just like instead of always overwriting the same save, just cycle through those 3 saves and make sure to save a lot because the game is definitely kind of buggy. So to clarify, journal agrees with principle is the solution to problem of induction might not always apply. Live the choices and the bugs? No. Well, I guess I'm not sure how this is related to induction. But I'm thinking like a way like it's a really common thing in stats classes where they show you a graph of ice cream sales versus crime. And both of them increase in the summer. But that doesn't mean that, you know, one causes the other. Like, ice cream sales don't cause crime and crime doesn't cause ice cream sales. Like, I feel like you shouldn't need to go to quantum mechanics to find a counterexample. I guess so. When I didn't see the problem with it before, I assumed it wasn't demanding that there be a common cause C. But I guess it actually does demand that there's some common cause or there's some type of causal relationship. I guess with the ice cream and crime example, you could make an argument that it actually is the third case C, where that's just the nicer weather. Maybe you do need an exotic counterexample like this. Now I don't think I would pay the $10 or get unlimited access since they only allow you to play 100 hours. That sucks. They do have a 24-hour pass I can use when I want to play longer sessions, not restart every hour. Oh, nice. Don needs to play Bloodborne on stream. I do. I wasn't happy with how the emulator ran on my computer. And I was thinking about the offer that you made me about the PlayStation, but I kind of realized that the ping would probably not be great. And that would be kind of an issue for a game like Bloodborne. Sony just needs to port it to frickin' PC like they have almost all of their other exclusives, just not Bloodborne. Leaders related to induction because if you can isolate what the cause of events are, you can induce future events to be caused by those causal relationships. I guess, okay, yeah. Oh, wait, sorry. I was imagining mathematical induction. You're talking about, like, logical induction, though. More sympathetic to frequentism than Bayesianism and probability theory. I couldn't tell you the difference. I believe frequentism is more objective by not factoring into account subjective priors. Okay, so maybe that's kind of the difference right there. That seems like a fair criticism. Yeah, it's I guess it'd be worth it to try Skirtle. I haven't been gaming at all because of just school, but maybe once I have some more free time. As of right now, I haven't even played a single game in like 2 weeks almost. How am I alive? Uh, I'm not. I I've literally wrote a 10-page paper that was basically my homework. Like just like there were just that many math problems to solve. That was due yesterday, and then on Monday I got a second 10-page paper that's due for a different class. That was my plan to work on for this stream. It's an equation to extend the weekend to 5 days and weekdays to 2 days. Oh, well, that's a quick one. Just, you know, do weekend plus 3, weekdays minus 3. Problem is implementing it, I think. Lots of images, air. Yeah, so like it's just like a 10-page maximum. Like it doesn't have to be 10 pages. This one is definitely gonna have a lot of images though, because it's about image processing, thankfully. So that's gonna fill up a lot of space. But it is like single spaced. I think so this is like homework 2. The first homework assignment was the exact same, or like the same like format. And I think I definitely got up to 6 pages. Maybe probably more. I don't remember. Computer modern as a typeface. You just recognize it? They gave us a template to use for our homework, so I'm not questioning it. Explain what type theory and category theory. Oh gosh, those are 2 very high level like niches in math. And I don't really know the first thing about either of them. Yeah, I'm sorry. I think I just can't do it. Yeah, those 2 things are really like out there and abstract as I understand them. It's a default LaTeX font. You dislike it? Oh, I don't mind it. I'm not much of a font person though. So I'll maybe read through this counterexample here, and then I might want to go back to doing my report. But factor employs a genuinely indeterministic process. The process initiated I has a probability of 0.8. The chemical is produced. Okay. Whenever the chemical is produced, the factory releases a pollutant P as a byproduct. Thus, 0.8 is equal to the probability chemical intersect, so they produce chemicals and pollutants given initiation. Sure. Stutters rise up. You know it. Quinter, thank you for hanging out. I'm doing all right. Hope your games go well. How do they get these two probabilities? I assume they're taking them both as 0.8, and that's where 0.64 comes from. I don't understand why they should both be 0.8 though. Well, I guess I do. Maybe. I did the hard part off stream last night, I think. So it should hopefully be smooth sailing after this. Neither C nor P cause the other. This just seems wrong. When you produce a chemical, you produce pollutants. How is that not a cause? This seems like some... This feels again like the probability word police are out here. And maybe I'm misunderstanding something about what it means to cause. Or like to be a cause. Hey Rex. Yeah, I don't understand this counterexample. Oh geez, yeah. This is maybe a little more reading than I'm willing to do right now to keep on talking about this, but yep. No worries, Energy. Thanks for trying me. I think there's something subtle that I'm missing with this, because it... I feel like these counterexamples are very weird. Yeah, and so that makes me think that I'm missing something here. The the principle itself seems reasonable enough. Maybe you need some type of extra condition for when it applies. But yeah. I don't know. Probability is weird. Which was easy to learn probability theory and statistics. Me too. Because it is really important stuff. It's just so awkward. But okay. Thank you for like starting that conversation. Hey, oh gosh. Seta Javira Mala, hello. And Dr. Trunkenstein, hello. There is no royal road to probability theory. That's true. Oh, Teja, yeah, that's right. I remember. Thank you for reminding me. Okay. So yeah, back to report writing. We're making an edge detection thingy with wavelets. What is the difference between YouTube and Twitch? I consider Twitch my primary platform. In my opinion, like YouTube doesn't really have a community for this type of math stream that I found. Twitch has a really cool little, it's very small, but a really cool niche for math and for education and live streams in general. And the people on it are just like generally really cool. So I say that the biggest difference is the community. I prefer Twitch. But in terms of like the technical ability, Twitch is way behind YouTube. Dr. Drunkenstein is asking to integrate log of sin x from 0 to pi over 2. There's an immediate issue there. Sine of 0 is 0, and log of 0 goes to negative infinity. I think it just is going to diverge. Because there's nothing that's going to rescue that to, like... If you integrate something that... Well... Yeah. Surely there's no way that this integral would converge, right? Is there a way, is this possible to integrate? Analytically? That's an interesting idea, Teja, trying to use like trying to split the sign up into a sum or something. Personally, I'd be curious about integration by parts. And you say log, I'm just gonna write actually no, you write log, I should write log. I'm gonna take it as base E though. Since we have a question, do you believe induction of causal relationships is possible in the social sciences, for example, economics? I am skeptical of that as frequentist because I believe human decision making isn't under similar conditions over long periods of time. Economic and technological changes occur, which make isolating cause and effect relationships difficult, if not impossible, in my view. I mean, I can't say I've thought about that all that much, but I do think you can only make very narrow statements when it comes to cause and effect. A general statement will pretty much always have exceptions. You could say, you could like try and soften the language and say like a cause tends to have this effect, but since you specifically say like social sciences, you probably can't make any firm statements ever. I wouldn't think. Kind of a systems approach. Think probabilistically, yeah. Uh, maybe Teja? I don't know. I feel better about integration by parts here than about your idea, but you might be right. Hey, K-Pars, you know about this? You want to look into mediation analysis and potential outcomes framework by Hernan and Robbins. Mediation analysis and potential out. Interesting. All right, so UV minus VDU. Integration by parts a second time. We should be okay. Already this thing is diverging though. So, well, this should diverge, but there's a limit to take there. This is like a L'Hopital's situation. Oh shoot, integration by parts. Okay, does anyone know the derivative of cotangent offhand? That's minus cosecant squared. Never mind. IBP failure case will happen? I don't think it's happening. I don't know there was a failure case. Mediation is when you have a complex causal path and observed association to explain through. The answer to this question given in the book is minus pi over 2 log 2? I would be very surprised if we don't get something that diverges. I agree with that, and since you can't have certain induction when it comes to social sciences, in my view, I tend to support free markets because I believe they decentralize economic decision-making in a way which accommodates people's needs more effectively than if a government with limited information made most economic decisions. Does that make sense to you? I view it as a spectrum, because when you say free market, you might not mean the same thing as someone else who talks about a free market. It sort of seems like a free but regulated market is the best thing, but there's a whole lot of like questions about how do you regulate it that come up. So poverty causes M1, causes M2, causes MN, causes heart attack. Oh, okay. Causal claim when you have like a chain of events. Oh, it'll be complex. No, I mean it's just integration by parts twice. Like this is we're done integrating now. Causal claims need to have a few criteria, what they call SUTVA: exchangeability, ignorability, positivity. Things enough to look further. Fair enough. Okay, first, I was just looking at this integral from the YouTube chat, but the thing that I'm planning to do, if there's any question from chat, is I is working on this report that's due on Monday using what's called a wavelet transformation to detect edges in images. So this is like the prototype example for just like making a map of what the edges are. Okay, so Yeah, PhD. This is um probably my favorite class that I've taken at UW. The instructor is really good at explaining things, and the homework assignments are really like authentic, meaning they reflect things that you would do in the real world. And yeah, it's a really cool class. That's to do with like motion amplification camera algorithms. It could be. I haven't heard of those though. Motion amplification. Show buildings and machinery swaying over a time lapse to show inefficiencies or stress points. I couldn't tell you, K-Pars. What I can tell you is that the way we're using wavelet transforms is when there's a sudden change in color in an image, that shows really clearly in a wavelet transform. So it's really easy to isolate sudden changes. I don't understand what that accomplishes, Dr. Drunkenstein. I don't know what to do with that idea. It might be right. I just don't know where to go with it. Using DUIs? Are they asking about, like, Feynman? What the hell is this? Oh, wait. Okay, this is a T substitution. Okay, I thought this was some crazy notation or something. So, okay, so this person is using the same idea as Dr. Drunkenstein. And Teja. Oh, uh, hmm? This person isn't a fan of showing their work. Why does this integral evaluate to minus pi over 2 ln2? Oh, does that integrate directly? I, um, or is it inverse trig that has the ln's? No, it's not, I don't think. Oh. Okay, Zach, I see what you're saying. I'm still not sure where this factor comes from. But okay, they're trying to arrange this because you can use log properties. Wow, that's sneaky. Let me give you the link. I should write it out. I I don't think I would be able to spot where the issue is, even if I wrote it out. Like, do these just combine into one thing? I'm kind of shocked that this integral converges. I guess because it's basically exponential decay when you take log going to 0. ln Oh, okay, Zach. Yeah, I guess I was getting it mixed up. I thought the 2 came from this 2 here, but that doesn't make any sense. Okay, so yeah, Dr. Drunkenstein, I can't see whatever you posted. Uh, links just don't come through in the YouTube chat unless it's like me who posts them. But yeah, I think this is just what you want here, Dr. Drunkenstein. This is I remember last quarter in my complex analysis class, this question came up with Fourier transforms, and that technically supposed to prove that the improper integrals exist before you do anything with them. But my professor literally said, if you, in my opinion, if you can find it, then it exists. Which I like that we could just do that in applied math land. I wonder if, but like, is there ever an example of an integral that diverges, but normal techniques would give you an answer that just isn't right? I don't know. Anyway, I'm gonna call it for that question. Go back to writing my report. So it's made one a specific counterexample? I guess so, probably. Depend what you mean by normal techniques. Rearrangement theorem would still give you some trouble. Rearrangement theorem? Oh, I didn't know this had a name. It does sound fitting, yeah. But not Tarski. I assume this is a different idea, but maybe they're related somehow. Okay, you know what? Why do you need to prove an improper integral exists? Hopefully there's a stack exchange thread on this. Oh, maybe it's like the principal value type of issue. You wonder what AI will say? Made a video looted climb but not Tarsky trash, so maybe maybe you're biased, maybe. Do tricks. Minus infinity to plus infinity to get a range of values. Maybe? Oh, for sine of x, yeah. Um I literally gave Google's AI one of my homework questions for my asymptotic analysis class, just out of curiosity to see if it could do it. And at one point, like the explanation was really long. I didn't read it all, I was just kind of like skimming it. But at one point, it literally said, "This is getting complicated. Let's slow down." It could not figure it out. Like it was saying the word in the question didn't make sense, and like it went down all these different paths of trying to solve the question but not being able to do it. One for five on the last five questions, math questions to LLMs. Want to waste my time for a while on information theory thing. I have given Chat GPT like um either Olympiad or like MIT integration be integral, and it actually, to my, as far as I could tell, it did do it correctly. Um, but yeah, I think it'll get there someday, pretty soon in the future, but it's not there like quite yet. Yeah, that should be my motto now. What would the AI do? It used to be, what would Macho Man Randy Savage do? But it's time for a change. Yep. Got to keep up with the times. Did it? No, I think it just did it all, like, as far as I know, it did it all on its own, Leo. Like, it started writing Python code? Give me a derivative of this rational function at this value. Oh, that's interesting that... I wonder if it actually runs the code or if it just predicts the output? I guess it probably predicts the output. It ran it. I didn't know it could do that. Um... So yeah, for my... I guess I'm happy to chat about whatever, but for now I'm going to be working on my report in the background. Not convolutions. Well, you could consider these convolutions actually, but letting AI execute the code it made. You know, that is a little sketchy now that you put it like that, K-Pars. Um, I have to write a report on wavelets, and we're using wavelets to do edge detection in images. These over finite fields did blur convolution as an example. Oh, nice. Well, homework assignment before this was FFTs for filtering data. Not doing FFT must be faster. You could just blur it directly. Probably like taking averages. Um, but yeah, basically with wavelet transforms edges in the image, kind of come up as like singularities in the coefficients. And a wavelet transform is just basically a Fourier transform, but localized in space or time. D is like, it's n log n for FFT. If kernel is small, directly doing it, get n squared, I squared, or probably L squared. Huh. And the kernel being small means you only need a few, like, terms? Or a few, like, coefficients? 3 by 3 kernel? Okay. So yeah, I kind of we were given a stock image to do this edge detection thing with like this kind of cameraman image, but part of the assignment was to go and like use our own images. So I kind of wandered around campus yesterday looking to stage a little photo. So I took this one in a library, and I'm kind of glad that I took this from Fallout. I have this tin of bottle caps, and I feel like it looks really cool when you put it through the edge detection thing. The Rubik's Cube too. I like the look of when you put it through this. Sample went up to 30 by 30, which might still be faster just doing direct matrix operations. Interesting. You should. Oh, you should you use the same image. Yeah, I think it's a popular one. Put my creepy eyes post it PFP in this report. No bias. Yeah, that's a great idea, Leo. Um, so yeah, last night off stream, I wrote the most annoying part of the report, which is like the theoretical background. It's I kind of had some trouble figuring out what to put here, but once I got rolling, I was able to kind of fill it out. There's like wavelet transforms aren't just one thing. There's many different types of wavelets that you could use. The one that's best for edge detection is the Haar wavelet, because it's, I think, the only wavelet that's actually symmetric. All the others aren't, I think. And so I chose this kind of like very asymmetric wavelet just as like a demonstration, dB20. So like the data is like as clean as you can get, literally just half black, half white. This should be really easy to detect this edge here, and so Haar does it well, but dB20 gives you all these like artifacts, I guess, or almost like echoes. What's the difference between wavelet transform and DFT? So a wavelet transform, it uses a different basis. Um, Instead of sines and cosines, there's many different bases you could use. Um, I mean, you can still use sines and cosines, and that will be called a short time Fourier transform. But the big difference is that instead of one parameter for frequency, you now have two parameters, one for frequency and one for shifts. Um, Trying to figure out how best to explain it, but basically, what is it? It lets you take a Fourier transform in just one section of your data. Like a regular Fourier transform is global; it'll tell you all the frequencies at once, but not if it how it changes over time. Suitably orthonormal. Yeah, there's people get fancy with it, and they're able to make there are some wavelets that aren't orthonormal but still work somehow, or not exactly orthonormal. Um, the easiest one to work with, because it's the simplest, like I've looked for information on them, and I cannot find a simple explanation, but the Haar wavelet is basically just a digital sine. So step up to 1, step down to -1, and then back to 0. And you shift and you scale, or sorry, you take dilations of it that represent your frequencies up and down, and then you also shift it left and right for one dimension transforms. So with motion amplification cameras, they detect edges, then find frequencies in the movement of the video. Random motion cancels, but periodic stuff sticks out. Ooh, that's cool, K-Pars. That sounds like something that Wavelets could help with. And hey, Yanis. Do computations with sines of cosines over e to the 2y pi k over n. I mean, that's just like a regular Fourier series, right? That's how we like define them. Like theoretically, but when we actually go to code stuff, the NumPy library handles all that. I'm doing all right, Yanis. How about you? Stressed with like, I'm just like homework and stuff, but what are you gonna do? I can show an example of a wavelet transform in kind of a cool case. Maybe it's this one? No, it wasn't that one. Homework will do itself, surely. Yep. If only. Exams are soon for me. I got quite a bit of studying to do. Good luck, Giannis. But yeah, we've been using an image of a raccoon for an example pretty frequently. It's gonna be easier to understand wavelets just with like a simpler wave like this. So the point of this signal here is it starts out low frequency. Oh wait, do we even use wavelets on this? Oh no, we didn't. This isn't a wavelet one. My bad. Surely it's this one. These are the wavelet transforms, but really? Oh, this is it. Okay. Before I showed the cool graph. You should do some more notebook coding things. Wonder if R is a notebook style thing. Maybe. I don't know. Jupyter notebooks are cool for certain things, but I'm not completely sold on them. Started with R years ago, and I'm stuck with this shitty language. Yeah, I'm an applied math grad student. I'm going for a master's. So yeah, this data is on ocean temperature over time, starting from some year in like the 1860s or something. You do pure math and theoretical computer science, so you dance around applied math. That's funny. You don't like actually doing things, you just like talking about doing things. So yeah, this data has like a long-term like fluctuation trend throughout it, but it also has like really short-term fluctuations too. And the thing that wavelets will do for you is it'll capture the frequencies in each part of the data. And for this data, it looks kind of cool. So this is what you get if you do the wavelet transform. So the horizontal axis is still time, just like before. The vertical axis is now period, so just 1 over frequency. High period is low frequency, and low period is high frequency. So it's kind of upside down, but this does look cooler. And this is colored in based on the value of the wavelet coefficients. This is the log of them. But basically, the stuff across the top here, there's very little dark blue, and that's what's capturing the low frequency trend, like this long-term like fluctuation all throughout the data. Is this like top part of the image. Does this work if the data has a lot of zeros? I imagine so, K-Pars. I don't see why not. What is the period? Like, you look for frequencies in what time segment ranges? It's the total period, the whole thing. It basically means like, so look, if you look only at the year 1900, this like vertical slice, it's like if you look only at that point, you can see what frequencies are present in that year, or like immediately around that year, like some small like neighborhood, I guess. So I think that they made it period instead of frequency just for aesthetic reasons. Asking, oh, what the neighborhood length is. I think that's what the period is controlling. The high period is a larger neighborhood, and the low period is a smaller neighborhood. Yeah, because these get you like details on different scales. And so defines frequencies based on each neighborhood. Yeah, I believe so, because I think what is basically happening if you use Haar wavelets. That's interesting. The background doesn't come along. So if we're looking at the year 1900, there will be a wavelet, or there'll be many different wavelets centered on this year, and every like we do this for every year. We have a wavelet centered on this data, and we do it with many different scales. So there's one Har wavelet that will be like, say, I should do a different color. That'll be that, I shouldn't do blue either. I guess red. One big Har wavelet that gets multiplied with the data like this. And then one that's half the width that gets multiplied by the data like this. And it'll get halved each time. So I guess it's many different neighborhoods that capture different scales of fluctuations. Is it symmetric? Like if you did this graph, it would be different if you cut off prior to 1900. Not symmetric, but do neighborhoods look at data before 1900? I want to say it's symmetric, or like I want to say it looks at before and after. Hey, Kirk. It sweeps over period lengths for the wavelet shape. Exactly, yeah. And so it does the same process at every like vertical slice. So this will get slid along for the year like 1940 also, and do all these same different scales of wavelets here too. And that's what gets you the all your different like frequencies. There are a bunch of different wavelets, not just this digital / square one is called a Har wavelet. It's the simplest one to think about. But there's a bunch of them. There's like 20 different families of wavelets, and those families have different wavelets inside of them. You have a few questions for today, and the first one is, what is that sun symbol there? Sun symbol? What sun symbol? I don't know which one you mean, Kirk. Hardly know her. For sound perception, there's a fixed neighborhood of a few milliseconds, and you get just frequencies in that period. Interesting. The funniest wavelet is the Har Har. Oh, like the sun symbol that's like right there. I think it's to insert an image. Yeah, it is. And then there's also the Sigma. You can actually do tech in this program. Oh, some! Oh my god! I'm illiterate. Yeah, this program is called Journal++, and you can actually type LaTeX. You can't see it, but a window pops up that lets you type LaTeX. And it'll insert the LaTeX into the thing. Does it give weird artifacts based on the sampling rate? I don't think so, K-Pars. As far as I know, like, at least not with the Har wavelet. Other wavelets might give some weird bit behavior. Because they're not as symmetric as the Har wavelet. It is a thing that at the larger scales, like the coarser approximations, you do literally lose resolution. Yeah, Journal++, you got it right. With the X and everything. So when we have discrete data like this, it only makes sense to go so fine for your frequencies, because they're just, it's physically impossible to capture really high frequencies if your data isn't high enough resolution. So it only makes sense to go up to a certain frequency, and that finest frequency is already like cutting your resolution in half, and then if you go down another frequency, you're cutting the resolution in half again, and each like coarser approximation has worse and worse resolution. But that's not necessarily like an artifact, I guess. Number of samples per time period per sample, right? Yeah. Oh, you know what? Okay, so uh you add sprite frequency stuff into the data manually because I want to. I want to redo this figure here. This takes up way too much vertical space. And I want to make it so it's like 2x4 instead of 4x2. These images came out pretty cool though. Testing the same thing in like light and dark environments. Did I do it? No, I did it in this file. Okay, how are we doing this? We want it 4x2. Remember the temptation of downloading all of Wikipedia today. It like I know that's possible. Like it's actually not that big, right? Maybe like 2 gigs. It's really cool that that's even like possible. It's way more? Oh, okay. I mean, without the images, I thought it was surprisingly small. Okay, let's just reverse these indices and see how it comes out. This might... I don't know if vertical is going to look good, but let's just see. Frickin' notebook. Frickin' matplotlib. No! Ah. That doesn't look too shabby. I don't know. Actually, I kind of want it. I don't know. I don't like that the pairs are vertical. I kind of want them to be horizontal. um, without images, it's around 30. Okay, that's still not bad. Orange Shoot, yeah. So this is a homework assignment to basically experiment with and write a report on wavelet transforms for edge detection in images. And so these are some pictures that I took myself of just things that I have around the house here, and applying the kind of algorithm to these. Put a bunch of random numbers into one of the wave transform graphs and retransform it back to the original data like it was hiding a secret code. Oh, that'd be a funny encryption method. And last quarter we had we talked a little bit about Fourier transforms, and we had a homework assignment where they kind of made a Fourier transform method of encryption where you like you take the Fourier transform, split the matrix up into blocks, and then permute those blocks. And so the next person, like, you know, you can send what the permutation is, and whoever's receiving the message could just reverse it and then untransform it. Steganography. Interesting. Add some bit shifts, do some XORs, do it a bunch of times, you'll get stream ciphers. Ooh, okay. Encrypted blocks YouTube is sending me? Oh. You know, okay, even if I go horizontally though with my pairs, I don't know. I don't know if that would look good. You like the vertical? Maybe I'm worrying about it too much. I should just go with this. Yeah. It's not that important. YouTube censored my awesome joke. Poor Olive stream. Oh yeah, we're missing out. Yeah, no, I didn't even see anything pop up. Oops, what did I? I don't know. Fuck something up here. No, I don't think I did. Just feel the humor. Okay. Sounds good, Leo. Thanks for hanging out. Have a good day. All right, I think this is a lot better. It's a lot better use of space to have it horizontal. So last night I wrote the theoretical background section. Let's keep moving forward into the algorithm and implementation and development section. For the reason they want you to list the packages that you used, and it feels kind of tedious, but we can start by doing that. The packages used to generate the figures in this report are NumPy, for arrays. We won't capitalize NumPy. Matplotlib for creating the figures themselves. Actually, that one should come last. Pi wavelets for wavelet transforms. SK image for image reading and scaling. And Matplotlib. Did I miss any packages? Nothing important. Okay, so what do I really want to say here? I want to compare HAR wavelets to other wavelets. I would love to have a source that I could cite for the statement here, that it's the symmetry of HAR wavelets that cause them to be good for edge detection. I don't have a good source to cite for that, though. So I'll need to think about that, or just let it fly with that statement. Other wavelet families have properties that are desirable for other purposes, but for edge detection, they can produce artifacts. To demonstrate this, oh, you know what? There's even more figures that I need to include here. God, okay. I'll figure that out later. Figure / site fig. Wait, ooh, what? Fig : Come on, auto could complete. Oh, it's ref. That's the issue. Dude, I can't type. Okay. Features a... Thank you, respect, Ronnie. Features a demonstration of HAR wavelets and... or of the HAR wavelet and the DV20 wavelet. The HAR wavelet. I'm kind of repeating what I put in the caption, and I'm trying to... What? No, go away. No one asked you. I want to... I don't know. I could just delete this entirely and include the information in the body. I don't have a specific schedule. If you're looking for a YouTube stream that does have more of a schedule, you could try, hopefully this command works. Actual education. He streams on YouTube also. He has an actual schedule, unlike me. I don't remember what it is, like, offhand, but he streams pretty frequently. am I trying to say here? Our wavelet. Fun fact incoming. Okay. You know what? I think we are going to steal this caption. I never cease being dumbfounded by the unbelievable things people believe. That's not a fortune, that's an opinion. What? Who would put that in a fortune cookie? Okay, maybe this is enough that needs to be said for this piece of it. My New Year's resolution was getting to solve a basic problem from all kinds of calculus with somewhat good understanding. Now it suddenly feels like 500 new types of calc questions were discovered because what the hell is a Malavian calculus, and what does that even mean? Oh wait, so the word calculus has a bigger meaning than like like calculus can refer to things that aren't what you study early on in a math undergraduate degree. Like it's completely unrelated. They just also call it other types of math calculus. Yes. So this is something completely unrelated, I think, to the calculus that I think of. Or maybe not, like, or maybe it uses like regular calculus somewhere, but it's its own branch of study. Fun stuff. Hey, Tizzer. Consider a Wiener functional f from the a functional from the classical Wiener space. Okay. What's up, Tizzer? This is a lot of symbols. You want to start with Calculus 2? I'm not able to find a good online course, like lecture format. Uh, do you try MIT OpenCourseWare? I haven't looked at their calculus stuff, but surely they'd have calculus. You did? Well, that's unlucky. It's only reading. I haven't gone on YouTube and looked for calculus lectures, so I can't recommend anything from personal experience. Um, can- I have heard good things about Professor Leonard. Oh, there's an MIT OpenCourseWare. That might just be first semester though. Oh. Um. This is not what I think of. Okay, like starting around lecture 7.1 is what I think of as calculus 2. Yeah, now that I see the name, I definitely recognize Professor Leonard, and I've heard people enjoy his stuff. I haven't watched any of this for myself. That's something. I think it's the best that I have for you anyway. Um, like sometimes the MIT OpenCourseWare YouTube channel has uh things that aren't easy to find on their general website. I'll take a look at that in a second, Kirk. Hey, Collar Cone. They don't say what's happening. Oh, hey, this looks just going off the thumbnails. Integration by parts. Oh yeah, that's a power series right there. Yeah, you can try looking in the later part of this MIT OpenCourseWare one. Oops, let's see what Kirk linked. I'm doing all right, Collar Cone. How about you? The worst way to solve quadratic equations. Wait, I didn't catch that. Oh, that goes way too quick. But there's literally there's a section on rocket science. Any book? Oh, not particularly. It's not a book, but I do highly recommend Paul's online notes. If I haven't already told you about that, and uh, I'm not that up on what books are good and what books are bad. I don't have much experience with calculus books, but I can tell you that this is a free and or this is a website that has free and legal textbooks. So I would also just pull something from here. Puzzle and Notes has some like questions too. Like each section has a practice. Uh, like I shouldn't most of the sections have like practice problems in like a little tab, but this should also. Oh yeah, string is good. Hey Q. But yeah, Paul does have a decent amount of things. Just look at the practice problems and assignment problems at the top of each tab. You guessed it, Keo. I am doing all right. Thank you. Hope you're doing well. Um, what else do I want to say in algorithm implementation and development? No worries, Tizzer. Thanks for the question. So we talked about different types of wavelets. We can talk about noise. Noise. Shoot. I need to make a new figure. Ah, I already have so many figures. So, um, basically, what I've already done is I took this stock cameraman image, I added noise to it. I added, we're told to do noise at 3 different levels. I was doing everything at like the highest level they asked for, but I need to actually make one at each of the 3 different levels. How do I want this to go? I don't know. All right, let's come up here. Point 0.1, 0.25, and 0.5, I think are the values we're supposed to use. Yeah. Uh, I don't know what to name this variable. Noisy. Noisy sigma, why not? Noisy noise, The noisiest of noise. np.zeros, not zeros, like just np.zeros. img.shape 0, img.shape 1. I think there should be a better way to do it than this, but this is the way I'm doing it. Sigma val, length sigma vals. Excuse me, do you not have enough parentheses already? Oh, you don't have enough parentheses. For I in range length sigma vals. Noisy sigma colon I is equal to sigma vals of I. Okay, so we've added noise at 3 different levels to our image. Now, for each of them, we need to do a discrete wavelet transform. There's a question here of whether I want to keep things keep my parameters consistent for all 3 of them, or if I want to change them. I think we want flexibility to change them. I think let's get each one as good as possible. So we'll have different thresholds for each. We'll have different maximum levels that we go to for each. I think we maybe want 3, 4, and 5. And actually, this could maybe simplify. These figures might not be necessary. I wouldn't use all of these regardless, but I might be able to not. I might be able to make these a lot. Like, I don't need all 3 of these for every single wavelet. Price working on generics. Sounds good, Kyo. Appreciate you lurking and working. Oh my gosh. Okay. Do I want 3 plots? 1 for each noise level? Do I also want to include the input image again? I don't think I need to. I think for the sake of space, we already have the input image once in the report. Let's not keep on repeating it, I think. I guess we'll make this generic, but... Ah. What am I doing? We're basically going to use a lot of this code again. Oh wait, I should make it noisy IMG. It's a better variable name. Just copy and paste and see what we want to change. My variable names are really bad. Noisy IMG colon I. Noisy levels, np.zeros. That's fine. Num levels should be this level vals I. PLT. Oh wait, no, I'm doing my plotting out here. We don't need you. Might make the fig size 12 by 4 though. That's not where I do that. Fig size equals 12 by 4. For I in range, max level vals I. What is this LVO? Oh. Yes, that's fine. Hey, Clunk. Cheer up. Things are getting worse at a slower rate. That's a terrible fortune. Maybe it's... I mean, it could be true, but... Um... What am I trying to do? Yeah. That that one's a bit of a sad one. Uh, so noisy levels. It's gonna have, for the first iteration, it'll have 3 different things. Am I getting confused on this now? I'm not sure if I need it here. Can I do just noisy sum? I think I can. Well, yeah. Don't need that. Noisy sum. Nosy some. Noisy some. Slash sigma equals sigma vals I. T equals threshold vals I. It's a very long string. Who cares? Okay, let's just... Oh, wait. Not yet. plt.tight layout. Don't want a loose layout. Bruh. Frickin' Jupyter Notebook. Well... It's not exactly what I want. I mean, that one is not bad. I made an indexing error. Index 3 is out of bounds. Which one? For axis 0 with size 3. What? Oh, wait. Ugh. This isn't the issue? But that was an issue. I don't understand how any of these are out of bounds. And why did the first one go in the third spot? Luck will visit you on the next new moon. Now that's a real fortune. That's a fortune I can get behind. Oh, wait, this is the last one for 3. No, wait. What? Actually, this doesn't make sense. List index out of range. This time in the one before. I don't understand. Is it? I now understand. It helps if you don't use the same variable to mean two different things. What a stupid, stupid mistake. Well, I think something's still a little wrong here, but this is progress. Sigma vowels. Sorry if you can't handle my sigma vowels syntax error. Not everyone can. Oh wait, I don't need this part at all anymore. Well, why does this suck? How do I make it not suck? Okay, theoretically, this 5 levels one should look the exact same as this one down here. Okay, let me make the threshold value match. 0.47. Why is it inverted? Well, I guess it's... I don't know, man. I do not know. What am I actually doing here? One golden eye. This seems right to me. Hey, looketh. I don't know what I'm doing wrong. I remember you. I've been to Japan, but that's it. Okay, I can't spot the issue with this. Come to India? Maybe one day. I don't know. Maybe I'll go back. I'll figure that out off stream, and for now I can go back to just writing this stuff out. Uh, what was my plan with this figure? Oh yeah, I was just doing that for the different levels of noise. Well, you pay for my plane ticket, Licketh. um, so I've talked about different types of wavelets. We talk about. I'm from America. I guess we can talk about noise. I go to University of Washington. This. Mm, everything I type right now feels stupid. um. I could bring in one of the other figures that I made. Like, this is one that I probably do want to use. Uh, are noisy different levels .png. Um, edge detection with our wavelets for a noisy image. When incorporating information from a different number of levels. Noisy level. Noisy diff levels. How's the width? That's fine. Okay. When noise is present in an image, edge detection. Actually, what did I say about this in the theoretical section? I repeated myself when noise is present in an image. Ugh. Fucking hell. Hey Dora. I'm working on a paper for a homework assignment. We basically have to use what's called a wavelet transform, which is like a version of a Fourier transform to detect edges in an image. So this is like the most basic, like, or this is like the kind of like first pass at doing it for this like stock image here. So this is like the image that we're given, and then this is the kind of like edges of the image that I found using wavelets. And from this like basic case, we do different things like adding noise, which is still possible, but it gets a little bit harder. Yeah, this isn't. I probably need to add in another one. Oh, maybe I should add in the input image for the noisy one here. But yeah, so this is the same a similar algorithm, but applied to a noisy image, and so the outline is still kind of there, but it's a little bit blurrier compared to this one up here. And then the final part was to take some pictures for yourself and apply the edge detection to them in different conditions. So when it's light, when it's dark, high contrast, low contrast. So this one, I kind of think this one came out pretty cool. Yeah. Hope you're doing well. Oh wait, yeah, I meant to read so I wrote the theoretical background section last night, and I'm trying not to repeat myself. It really annoys me that this quote doesn't, like, the opening quote isn't reversed. And I don't know if that's a LaTeX thing that I can fix, or I don't know. But I wish this one was like reflected. It just looks weird like this. Maybe it's a font thing. I don't know. Okay. Okay, so don't I think of a new way to phrase this. uh Applying the wavelet transform to a noisy image requires using information from multiple levels. Um, much like the choice of threshold, the number of levels to use depends on the image and must be found by experimentation. For a higher amount of noise, you know, this this figure doesn't necessarily accomplish what I wanted to accomplish now that I actually start to write this out. This is the frustrating part of writing these reports. It's like figuring out what figures I want and trying to like tell the right story. Because like for the point I want to make here, I think it's better made by the figure I was trying to make that I just gave up on a few minutes ago. I don't know. For a higher amount of noise, the more levels. Actually, the higher the amount of noise, the higher the amount of noise present, the more levels must be used to filter out the noise. However, this comes at the cost, since each level has half the resolution of the previous one, this comes at the cost of less precisely defined edges. Is that a proper hyphenation? Precisely defined. I don't think it is. Precisely defined. I don't know. All I know is that I love hyphens and I would put them between every single word if I could. And I try to make sure that I don't do that. Switch this figure out for... And that should kind of be a computational result. Decisions. It's also difficult, like, not to have each of these sections cannibalize each other. Wavelets other than the R wavelet generally seemed to produce worse results, but I want to be more specific. This is me just, oop, that's not the right window. This is me just like jumping around as things pop into my head. I guess like if I compare this image right here to this image right here, the top one uses Har wavelets, which I'm claiming is the good one. The bottom one uses not hard wavelets. This is by orthogonal. I'm trying to describe why this one is worse than this one up here. And bi-orthogonal has completely missed certain edges, and the edges that are there are less precise. Results in that some edges are lost in the noise and other edges are what are other edges? I want to say not well defined. I mean, I guess that actually works. Now, am I going to hyphenate this? Well defined. No, I want to hyphenate it, but I'm not going to. So actually, I might be happy. Coming back to the thing I was saying before, I might be happy with this figure being matched with this paragraph. I almost think I should go one level further to show the results getting worse again, though. I think with the way I made my code, we could quickly see how that looks. If I just make this 5 into a 6, I think that's all it takes. Oh, that's not worse. That's an issue. Really? Why are these getting worse? Okay, that's worse. Okay, good. If I was getting worried that I was gonna have to like come up with a new storyline here. I would say even so, my level I was saying was the good one was level 5, and balancing, not having too much noise, and still capturing edges. So like the tripod, you can still see some of the tripod in level 5. You can't see any of it in level 6. Level 4, it doesn't have that much noise, but it does have a little more noise than I wanted. Honestly, let's try fine-tuning the threshold a bit. Could we make level 4 the good level? That's not too bad. I think level 4 with this threshold is better than level 5. And it's kind of interesting that the tripod is the detail that you lose first. That makes sense, because the tripod is very thin, whereas like his coat, like there's a lot of space that his coat takes up, and the legs of the tripod are, again, like thin. So I have a hard time putting it into words for why, but I feel like it makes sense that the bigger blob is more robust in the noise. Okay, so we need to make this our new figure. What was I calling this file? Hard, noisy, different levels? Or level comparison figure? Oh my god. Which one is... I just click out of this. Okay, level comparison figure. No. Hard, noisy, different levels. Okay. Hard, noisy, diff levels.png. Delete. Move. Download. Okay. Um, did the music just stop or is it just quiet? It's just quiet. Okay, so now let's reference this figure. Figure, fig, noisy, different levels. Shows feels like such a like I feel like I should have a fancier word than shows that I can say, but I don't know. Depicts, that's a fancy word. Um, this trade-off. I will hyphenate this. This hyphen is non-negotiable. It's just, I mean, do you hyphenate trade-off? I don't actually know. Trade-off. You don't hyphenate it? You do hyphenate it. It can be one word? No. I'm using a hyphen. Depicts this trade-off. As more levels are included, the amount of noise goes down, but at the same time, fewer edges are captured. The thinner edges, such as the legs of the tripod, are the fewer edges are captured. Edges that correspond to thin objects, such as the legs of the tripod, are more susceptible to getting missed as more levels are used. Am I using fewer correctly? Would Stannis Baratheon approve of this? I think he would. Wait, well, you wouldn't count. Maybe it is less. Also, the difference is really stupid. So I shouldn't care. Okay, that feels like a nice discussion on experimenting with noise. Algorithm implementation and development. Um, I could say something about, okay, so about having to experiment with the threshold values. So I don't think I addressed this in the theory part. Yeah. I mean, do I need to though? I mentioned it briefly. Yeah, it's fine. We might call this section good for now. For meow. Computational results is where we're gonna have a lot of figures. I feel like maybe we could write the introduction though right now. Hmm. Okay. Wavelet transforms can be thought of as a localized Fourier. Ooh. Do I capitalize the T in Fourier transform or not? This is pretty meaningless, but I'm going to debate this nonetheless. I'm going to not. In that they give information about the frequency at each point in space and or time. Or in space-time. Wavelet transforms can be useful in image processing. I feel like this is like I could try and find a few random papers that use wavelets for different things and just kind of cite them so I have something to back up because they're used a lot in like medical imaging, uh, like with MRI scans and stuff like that. I think actually wavelets. Uh, just search wavelet. Actually, I've been struggling to find a paper that talks about the different types of wavelets and compares them. Ooh, please tell me you're gonna do this for me, paper. Not necessarily about the applications, this is just the construction. What a weird looking function. Okay, wavelet analysis examples. Chirplet transform. That's a new one for me. Ooh, that's a cool looking picture. This feels like a level for some platformer. So does this. This is like Bowser's Bridge. Okay, this isn't... Okay, I'm getting distracted. Maybe I shouldn't be looking at random papers right now. Just write a comment. So we have something to cite. This report investigates the use of wavelets for detecting edges in images. Aims. Uh, dur, 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 dur. It begins. I think I'm getting better at writing in that stupid academic voice, where you always use like the passive voice for things. It begins with not investigate. It begins with a discussion on exactly how the discrete wavelet transform can be used to detect edges via thresholding, then adjusts, then an adjusted. Arendelle, can you use ChatGPT for those wordy parts? I could. I wouldn't, but I could. Welcome in. As annoying as it can be to write this, I think it is helpful to go through this process of struggling to figure out how to phrase stuff. Um, I don't remember offhand what this class's policy on AI is, but I can't I don't think it's open season on AI. Even if I wanted to. Um, discussion how it is discrete how then how the technique, where do we use the word technique in this section? I don't think I have. Can be adjusted for noisy images. What else did I say? Okay. And finally, applies this technique to a variety of sample images in different conditions? To a variety of sample images. That's good enough. How does discrete wavelet transform relate to wavelets? That question comes to mind. Okay. Thank you for pointing that out, because I've been using them almost interchangeably. I guess I'll explain it out loud what I mean first, and I'll figure out how to incorporate this. The wavelet transformation is a very like general thing. There's a continuous wavelet transform, and then there's a discrete wavelet transform. And within each of those categories, there are many different types of wavelets you could use. And I guess this is weirdly inconsistent, but like I've been talking about the discrete wavelet transform when talking about practical image processing. And like whenever I'm actually applying the discrete wavelet transform versus talking about wavelet transforms in general. It is kind of weird. I'm capitalizing this transform, but not that transform. I think I'm not quite sure how to explain the difference, because I think you can use the continuous wavelet transform on just like an image like this too. Okay, maybe okay. This isn't really addressing the question, but I'm out. I'll narrow down the discussion by saying this report investigates the use of the discrete wavelet transform. And maybe I should just capitalize all my T's and transforms. This is way less important than I'm making it. What other transforms do I have? Wavelet. This is where Control F comes in handy. But I like doing things the old-fashioned way and making stupid mistakes for no reason. DWT. It's worth considering. I feel like I'm not saying it that often, though. Hmm. I guess I'll... Our... No, I'm gonna not capitalize that. Okay. Let me add on to this comment. Talk about discrete versus continuous. Transform. So I have to do some more thinking about what the difference actually is. We didn't really get into it during lectures or anything. So if I'm going to talk about that, I need to go and figure it out for myself. Basically, yeah, collar cone. The different basis is special because it includes a shift also. So it gives you local information about what's happening in kind of each neighborhood of a point versus globally. But yeah, it is just a Fourier transform with a different basis. I keep wanting to say when noise is present, but edge detection can still be done on noisy images. However, there is a cost in the amount of detail that is possible to recover. Images, actually, I want to include a reference to this figure, which is this figure here. Why do I want to recover? I mean, maybe recover isn't the best word, but what I'm trying to talk about is I took the same stock image of the cameraman, I added noise to it, and I'm trying to say that we can still do edge detection on this noisy image, but certain details are just kind of permanently lost unless you get lucky or you really like fine-tune things. So when I went and tried to do edge detection on the noisy version here, like the legs of the tripod no longer get picked up because they're just like a little bit too thin. That's what you can see like here. It's like the legs of the tripod in this middle one, you can kind of see them, but it's gotten kind of lost. Versus when there's no noise, you can pick them up really well. Basically, yeah. How noise affects edge detection. And just like whether and how you can do it in general. You put it as the first sentence. Yeah, honestly. Just take this paragraph and put it down here. Um, the hmm. To get credits for the course. Yeah, basically. Edge detection. Okay, so I'm thinking about saying something about how this relies on contrast, and also how we're only talking about grayscale images here. I'm also trying not to repeat what I say in the theoretical background section. um, yeah, I mean, I think I want to say that this addresses the goal, which is to detect edges in images, and then this paragraph down here will be like the why of it, which this is used for like medical imaging technology and stuff like that. Also, I imagine this is done in the background for art programs. Like, I imagine when you use like the magic wand tool in an art program, it's basically doing this or something like this. Um, Still trying to figure out where this should go. Maybe I should just start writing something though. I mean, it's not just noise. It's about just the fact that it's possible in general to detect edges. I think like I would put them on equal footing. Just like the fact that you can detect edges with wavelets and that you can still do it through noise. Um, Dang it, I. Okay, what we can say is, ed, I'm kind of repeating myself a little bit here, but I think some amount of that is maybe okay. No, I might just I might just move this first part into the introduction. Holy crap, it's been 3 hours. I don't know. I feel like I'm starting to get writer's block a little bit. I might I think I might just call things here because I feel like I need to give myself a break and come back to this. I think let's do that. Yeah. Um, Bam. Okay. Catboy. Oh, we can do that. It's up to you. If you want to, you have to redeem it again. But if you want to do it, I'll do it. Okay. We'll do a drawing, but before we wrap things up. Paper color. It's not, that's a really depressing shade of white. It's a better one. Okay, Catboy Dawn. Okay. Guess I'll start with the pants, like I always start. That my feet aren't that big, dude. Okay, you know what? Try again. Terrible. Good enough. Terrible. Good enough. Okay. Um, my shoulder's a little banged up there. Okay. Uh, I'm starting just by getting me in here, and we'll work on making it cat me afterwards. What is this masterpiece? I have a channel point where people can make me draw things, and so I've been made. I'm being made to draw myself as a cat boy, apparently. So as you can tell, I'm a very gifted artist. I get the beard in there, the stash. Get some eyes. Maybe I just won't have a nose. I don't know where to put my nose, so I'm just not gonna have one. Okay, now we need to make it more cat-like. So that ear's a little bit too big. That's a little too big. It's a little too much to the side. Okay, cat ears. Voldemort dog. Yeah. No nose. Um Now I'm tempted to just try to draw paws instead of hands. I feel like it's gonna look really creepy. But I could have a paw on my shirt. Like a picture of a paw. How does a paw print look? I need to Google image search paw print. Cat paw. Okay. Um Kinda-ish. Okay. I feel like I need to make it more catty though. Like this is just mildly cat boy. I want to make it very cat boy. A tail. Yeah, okay, color code. You and I are on the same wavelength. I guess I'll make it the same color as my hair. I'm definitely winning Leo. Because I'm doodling. You know, I can fill in the cat paw as well. I can do a little speech bubble and say meow. It's not really... Ugh. It's a little better. Oh, yeah! The fangs would be a little hard to get in there. I made my head a little bit too small, but whiskers we can definitely do. Wait, maybe just 2 whiskers. Now we'll do 3. Cat bowl, yeah, that's a good idea. Um, is this how you draw a bowl? No. That's not really how you draw a bowl either, but it's gonna have to do. Actually, okay, I was gonna put water in there. I think kibble will be better though. And we can also make a litter box too. Oh, put my name on it? Okay. It's a good idea. Put it in green. Why not? Okay, litter box. Uh, I don't think this perspective is going to be quite right. It's definitely not right. It's right now. I basically put it on its side. Hmm. Kind of better, not really. Actually, cat litter. It's kind of that color-ish. That color, maybe. Let's see how this looks. Kinda. It's a little more gray than this, but this will do. Okay. Anything else? I don't know. I this feels pretty catty to me now. I'm trying to think of what else like of what else cats have, but this feels like the essentials. We could also make a water bowl, I guess. Hey, Ashwin. Okay. I'm not gonna put a turd in the litter box. But other than that, this feels pretty. A scratcher? That's true. Okay, yeah. We'll do one of those scratching posts. And then I think that might be good. It's 3 a.m.? Jeez. Should be asleep. How do these things look again? All right, sounds good, Ashwin. Thanks for saying hi. Thanks for the follow, Arendelle. These are like the ropes. They had to scratch. Okay. I mean, I could use a little bit more shading. I'm gonna mess it up, but actually no, it's gonna look like the ropes. Never mind. I'm from America. Maybe it won't. Nice. Ashwin. I don't think I made it better by coloring this in, but it's already here. Okay. I think we're calling this an image. Okay, see ya, Ashwin. Color code, thank you for the redeem. I think now it's time to call it. Oof. Thank you, thank you. Glad you like it. Okay. People here on YouTube, thanks for being here. I'll be back at some point.